Good afternoon, everyone. Good afternoon. Hope all is well. Hope everyone's doing all right. I still got a couple that are trying to connect with the audio, so we will give them a second and then we'll get started. All right, looks like everybody's in. Yeah, I was wondering. All right. All right. So we're looking at 6.5. Last class, we closed out 6.4. So we're looking at 6.5 today. And that's combining probabilities. Yep, no problem. Combining probabilities, and it is the last section in chapter 6. So this is all we'll do today. And next class, we'll be looking at, reviewing, see if anybody had any questions that were generated over the weekend, stuff like that. Because like I said, that will be all of chapter 6. And so we'll be looking to prep for 5 and 6 tests. I need to post that review as well. So I'll do that try to do it before tomorrow's out. Chapter 5, chapter 6 review. But anyway, let's get through 6.5 first. We have and probabilities for independent events. So we have and probabilities and or probabilities. Right now we're looking at and probabilities for independent events. Two events are independent if the occurrence of one event does not affect the probability of another event. All right, scroll up some. Of course, if I scroll too far, let me know. So purple says the probability that events A and B occur together is when you take the probability of A multiplied times the probability of B. So once again, whenever we're dealing with and, we're going to be multiplying, and we're multiplying the two probabilities together. All right, let's look at the first example. Suppose you toss 3 fair coins. What is the probability of getting 3 tails? All right, so flipping a coin 3 times are 3 independent events. In other words, when you flip the coin once, it has nothing to do with flipping the coin a second time. It doesn't play on or mess with the probability of what will happen next. Like I said, they're independent events. So we talked about the probability of tails before, or probability of heads. We know that's 50%. It's 1/2, 1 out of 2 chance of getting tails versus getting heads. And since they're independent events, and we want to know what's the probability of landing tails 3 times in a row, we're going to multiply 1/2 times itself 3 times, and that'll give you 1/8. All right. Questions on that before we look at the next one? And I scroll up. All right, so the last one was the and probability for independent events. This time we're looking at the and probability for dependent events. So if your events are dependent, that's when the outcome of one event does affect the probability of another event. All right, done with red. So the probability of dependent events, A and B, excuse me, probability that dependent events A and B occur together. Once again, we're dealing with and, so we're doing multiplication. So we do the probability of A times the probability of B, given that A has already occurred. All right, so we have a 3-person jury must be selected at random from a pool of 12 people that has 6 men and 6 women. What is the probability that's selecting an all-male jury? Probability of selecting an all-male jury. All right. So we're looking at the probability of getting 3 men. So we're looking at the probability of selecting a man first, probability of selecting a man given that the first person was a male, then the probability of selecting a man given that the first and second persons were male. And those we're multiplying these together. All right. And so to finish it off, I won't say finish it off. So to go through with the calculation, notice that in the first probability, the probability of selecting a man, that's 6/12, because we have 6 men and 12 people all together. Once I pull that man out and set him aside, there are 11 people left in total, but there are only 5 men left. So 5 out of 11 will be what we're left with for the second probability. Then once I take that man out, set him aside, there are 4 men left and 10 people left altogether. So in each case, numerator and denominator, top number and bottom number, they should decrease in 1 in all 3 cases because we're taking a man out of the category, out of the group of people to pull from. Then once you have your probabilities, you go ahead and multiply those together. That'll be 120 over 1320, and that'll be 0.091. And always make sure you pay attention to math lab on what they want from you, whether it be fractions or decimals, how many decimal places they want, and so on. All right, any questions on that one before we go to the next one? All right, can I scroll up? All right, a polling organization has a list of 1,000 people for a telephone survey. The pollsters know that 433 people out of the 1,000 are members of the Democratic Party, assuming that a person cannot be called more than once. What is the probability that the first two people called will be members of the Democratic Party? All right, scrolling up. So we want to know what's the probability that the first two people that called are Democrats. So we know the first one they were trying to pull out as a Democrat, probability of getting a Democrat on the first slot is 433 out of 1,000. We know that there's 433 out of 1,000 that are Democrats. Then the probability of getting a Democrat, being that the first person I chose was Democrat, will be a countdown from the numerator and the denominator by one. So it'd be 432 over 999. We took one of those Democrats out, one of the 433 out. So that's why that's 432. And then in total, it would go from 1,000 to 999. And then from there, you multiply them together. You get 0.1872. All right. Questions before we go to the next one? All right, scrolling up. Anybody holding on to the red? All right. So now we're going into OR. It's the either or probability for non-overlapping events. Two events are non-overlapping if they cannot occur at the same time. So if A and B are non-overlapping events, the probability that either A or B occurs is just going to be adding those two probabilities together. So and means you're going to multiply probabilities, or means you would add the probabilities. All right. So suppose you roll a single die. What is the probability of rolling either a 2 or a 3? So we just finished talking about non-overlapping events. In other words, events that occur that cannot occur at the same time. Or in other words, they don't have anything in common. So when I look at rolling a single die, what's the probability of rolling a 2 or a 3? Is it possible to be 2 and 3 at the same time? So those are two non-overlapping events. So if we just look at the single die, and the sample space for the single die is 1, 2, 3, 4, 5, 6. That means I have 6 total outcomes. And so looking at the probability of rolling a 2, there's only 1, 2. So that's why it's a 1 out of 6 chance. Probability of rolling a 3, there's only 1, 3. So that would be 1 out of 6 chance as well. All right, questions so far? So we want to know the probability of rolling a 2 or a 3. You just add those two probabilities together, and that would be 2 over 6, which will reduce down to 1 over 3. All right, problems before we look at the next one. All right. So next one, either or probabilities for overlapping events. The two events A and B are overlapping if they can occur together. So overlapping events, the probability that A or B occurs is going to be probability of A plus the probability of B minus the probability of A and B. All right, so a single die is tossed. What is the probability of rolling an even number or a number greater than 2? So we know our probability, and our probability, our sample space is 1 through 6. So number of our sample space is 6. Then if you're talking about the probability of rolling an even number, the even numbers that we have are 2, 4, and 6. So it's 3 even numbers. The probability of getting the even number is going to be 3 out of 6. Then a number greater than 2. You have 4 numbers that are greater than 2. 3, 4, 5, 6. So that probability is going to be 4 out of 6. All right. So now we have to be careful here. If we were to add these two numbers together, and I have my eraser on, nice. All right. Add these two probabilities together, that would give us 7/6, which would be a probability that's greater than 1. If you remember, our probability is supposed to be between 0 and 1. So we know there's something's going on here. So when you look at the even number has the numbers 4 and 6 in it, but greater than 2 in our sample space is also 4 and 6. So we have these two numbers that are being counted twice, here in the 3 and then here in this 4. And so we're talking about numbers that are even and greater than 2. And that's what it means by two events that overlap. They're two events that have something in common. And so these two events have two things in common, two numbers in common, which are 4 and 6. And so the probability of getting an even number and a number greater than 2 would be 2 out of 6. All right. Any problems before we finish it off? So now that we have the three pieces, we'll do the probability of even plus the probability of greater than 2 minus the probability of even and greater than 2. And that'll be 5 out of 6. All right, questions, any questions? Let me see, is that the last one? Yeah, let's try doing at least one more one. This should be good. All right, so to improve tourism between France and the US, the two governments form a committee consisting of 20 people, two American men, four French men, six American women, and eight French women. If you meet one of these people at random, what is the probability that the person will be either a woman or a French person? All right. So you want to know what's the probability that the person will be either a woman or a French person? Let's look at the event of being a woman. We know that the sample space is 20. We have 20 people altogether. Yep, 20 people. And then you say, well, how many women do you have? So we have six American and eight French. So that's 14. So it means the probability of getting a woman is 14 over 20. All right. Everybody okay with that? Next, what's the probability of getting a French person? So the number of French people here, we have four men and eight women that are French. So that'd be 12. So the probability of getting a person that is French would be 12 over 20. All right, so it is possible to be French and a woman and French. So it's only a woman and French. Once again, we have 20 people to select from altogether. And then I believe there are eight French women. All right. Any problems before we finish it off? Make sure we're good. So now that we have all three pieces, we'll take the probability of being a woman plus the probability of being French minus the probability of being a woman and French. That would be 18 over 20. Which will reduce down to 9 over 10. Questions, questions, questions. All right, so everybody okay? Everybody calm? Okay. So that's it for chapter 6. The next test should be test 3 for us. I'm just going to post that in Math Lab in chapters 5 and 6. First one was 1 and 2, second was 3, 4, and this one's 5, 6. So next class, I'll open up the floor for questions. It'll be opportunity for review. You guys to ask whatever you like. Let's see, so it's in the chat. I need some help with using the Z chart. Okay, so somebody had a question about the Z-score chart. Did anybody else have any general questions before we close out? Everybody okay? All right. So if you want to stay back for your classmates' questions about the Z-score chart, then feel free to do so. If not, have a great weekend, be safe, and I will see you on next class. So you say you have a question about the Z-score chart. You have a good one as well. How would you like me to help you? All right. Okay. Yeah, no problem. Mm-hmm. Yeah, no problem. Okay, it's not letting you unmute. Okay, in other words, now You said after a certain point. Let me see. Oh, if you have a question, you can ask it right now. I'm trying to figure out uh what it is I can do to help your classmate. But if you have a question on the Z-score chart, feel free to, either unmute or type it in the chat. So, and that was for Davis. It was Davis. That was White. He said, all the questions wrong for 5-3 after following the steps. Now, let me see if I can get in there real quick. All right. Hopefully it'll let me in. Okay, there we go. It says something about unable to. All right, so all right, so let's look at number 4. I know I actually I put this one wrong. Hold on a second. Oh man, I put this on the wrong page. Okay, I'll just put it up there later, transfer later. Perfect. Okay. So this was actually 5.3, number 4. Somebody asked me about that from the previous class, in which I'll show it to you. And you can let me know if this will probably that you dealt with, number 4. The 5.3 is normally distributed with 79 kilograms. And then the standard deviation is 20 kilograms. What percentage of individual adult males have weights less than 82 kilograms? And then if the samples of 36 adult females are randomly selected and the mean weight computed for each sample, what percentage of sample means are less than 82 kilograms? So is this one a good one to do? You can let me know. Okay, cool. All right. So let's go to my notes. So I already written down the given information. They gave us the mean to be 79 kilograms, gave us a standard deviation to be 20 kilograms. And then they wanted us to know about it being less than 82 kilograms for A. And then in B, they gave us a sample. Then they want to know what's the probability that the sample that you pull would be less than 82, would have a mean less than 82 kilograms. So let's look at A first. So with that type of situation, all you would do is just use your Z-score formula. Here's the symbols, but if you don't know the symbols, it's always your data value minus the mean divided by the standard deviation. And so that's why I have 82. The data value in question was 82. We're talking about being less than 82. The mean they gave us was 79. Standard deviation they gave us was 20. And if you were to put that into the calculator, you get 0.15. And even if it ran longer than 2 decimals, you always want to round your Z-scores in 2 decimal places. Questions on that? Oh, let's see. Let's see. Okay, good so far. Cool. All right. So now we go to the chart. So let's go to the chart. I should have it already pulled up. All right. So I can get out my way. All right. So we're going here to look for 0.15. I could have left that up there. I just had it. But 0.1 is right here. 5 is right here. And where they meet is going to be the value that we pull from the chart. So that's 0.5596. And so that's where I got that value from, 0.5596. All right, questions on that? All right, so now, if I gave you the 3 scenarios as to how we use our z-scores, you have less than, greater than, or between. I forgot what section that is, probably 5.2, that, yep, there you go. So if it's less than, you always use the chart value. Greater than, you take the chart value, subtract it from 1. And then between, you would just take the 2 chart values, subtract it from each other. So those are your only 3 scenarios. And so we have, or we're dealing with less than. So we're just going to use the chart value. So chart, that's what I was saying right here. Chart always gives you less than. And so that 55.96, they said, if you look in Math Lab, they give you a box with percentage on the side. That means they want you to convert it to a percentage. So you move your decimal 2 places to the right. I guess I put it up there. 2 places to the right. So that'd be 55.96. And then they also say round it to 1 decimal place. So that 6 will take that 9 up to 10. So that's why it rounds up to 56.0. All right. All right, not a problem. Now B is a little has 1 extra step that A didn't. Excuse me. But questions on A? Anybody that's in the room? Anybody have a question on A? Oh, it was just one, just you. Okay, cool. All right, so now when it comes to B, let's go back to it. B says if the samples, now this includes a sample, so that's the first difference. That the sample of adult females are randomly selected and the mean weight is computed for each. So now you're trying to find the mean for each sample. What is the percentage that the sample means are less than 82? So now you're trying to find what's the percentage chance that when you create this sample that the mean will be less than 82, not just the number. So here we go with that. So this is going to, the mean is going to stay 79. Standard deviation though now has to be, our new standard deviation is going to be the old standard deviation divided by the square root of our sample size. Our sample size, I think I wrote it up here. Yeah, our sample size is 36. So that's how we get this value right here. All right, so you said it's in the chat. Sorry, it's found an email to one of your classmates. All right, cool. And so now you just set it up the same way we did the other one. Once you convert this here, that's your bottom number now, and we use that 82 minus 79 over this number. And you want to carry your decimal out maybe 4 or 5 decimal places just to be as accurate as possible. Ended up getting 0.90. And then you go to the z-score chart again, the same way we did the last one. and we ended up getting 8.8159. And once again, we're dealing with less than, so we use that value, move your decimal 2 places to the right, and then once again, they wanted one decimal place, so it's 81.6%. All right. Mhm. So this is 0.90. 0.9 is right here, 0 is right here, and 0.8159. Yep, not a problem at all. So if that's all you have, then just let me know next time if you can think of anything else. All right. Did you have any other ones for me? Let me see. Okay, all right, sounds good. All right, you have a great weekend. I'll see you on Monday.